Hello everyone, today we're going to look at implicit differentiation. So far we've only differentiated what are called explicit functions of x, so y is some function of x. But what about things like x squared plus y squared equals 4, or 3xy minus y squared plus 4 equals x, something that I can't solve for y. What we can do is we can still find dy dx even though we can't find y itself. And the keys to remember in order to do this are the following. The derivative of y is dy dx. Y is some unknown function of x, which means we're going to be using the chain rule. And lastly, we're going to need some algebra skills. So, find dy dx. We have x squared plus y squared equals 4. So I'm going to differentiate both sides where, according to my thing here, x is my variable. So remember, the denominator is telling you what the variable is. So my variable is x. Anytime I'm differentiating a variable that is not x, I have to remember the chain rule. So to differentiate x squared, it's just 2x because x is my variable. However, to differentiate y squared, I take y as some unknown function of x, and therefore it's the chain rule. So I differentiate as if y were my variable, and I would get 2y. And then I have to, by the chain rule, multiply by the derivative of y. The derivative of y is dy dx. Okay. The derivative of 4, it's a constant, so it's 0. So that's how I get my dy dx in. Every time I try to differentiate a variable that is not my denominator, I need the chain rule, which implies a new derivative. Okay, so I have 2x plus 2y dy dx equals 0. I want to get dy dx by itself. So I'm going to subtract the 2x, divide by the 2y. So I have negative 2x divided by 2y. I'll clean it up, and I get negative x over y. So let's see what this means. Remember, the derivative is the slope of the tangent line. So if I were to graph this function, x squared plus y squared equals 4, is a circle of radius 2, because the square root of 4 is 2. So all of these guys up here are 2 and negative 2. Okay. So if I wanted to find the slope of the tangent line to this guy, the point is 0, 2. And if I plug it into here, I have negative 0 over 2, which is 0, which gives me my horizontal tangent line. If I wanted this guy over here, this is 2, 0. So I have negative 2 over 0, which is undefined. Undefined slope is a vertical line. Okay, so it does match up. If I wanted to pick, say, this guy, that was not a very good tangent line. This guy. This point, in theory, if I drew that the way that I wanted it to, would be root 2, comma root 2. And I'd have the same thing over each other, so negative root 2 over root 2, which is negative 1, which is hopefully the slope of that line that I drew. So even though my derivative now has x and y in it, it's still the slope of the tangent line. Okay? So let's try another one. 3x squared times y plus x equals 12. So the derivative of x is 1. The derivative of 12 is 0. So it's the 3x squared y that we have to watch out for. So I'm going to do it over here. So we have 3x squared times y. I have a product, which means I need the product rule. So the derivative of my first part, 3x squared, is 6x. So that's my u prime times my v. Then I need to add to it v prime u. So u is my 3x squared. My v prime, my derivative of y, is dy dx. Okay, the derivative of y is dy dx. So when I put it all together, I have 6xy plus 3x squared dy dx plus 1 equals 0. Again, I want to solve for dy dx. So I'm going to bring the 1 over, bring the 6xy over, and then divide by my coefficient, which is 3x squared. So negative 1 minus 6xy over 3x squared. Let's try another one. Y plus 4xy equals 1 plus x. Derivative of y, dy dx. Derivative of 1, 0. Derivative of x, 1. And then just like before, in order to do 4x times y, I need the product rule. So the derivative of 4x is 4 multiplied by y plus the derivative of y, dy dx, times 4x. Okay. The biggest mistake I see people do is not using the product rule. I have 4x and y, they are being multiplied. That's a product. I need the product rule. So let's clean this up. Dy over dx plus 4y plus 4x dy dx equals 1, just like I said before. Again, I want to get dy dx by itself. So I have dy dx plus 4x dy dx on one side, and I'll subtract the 4y to the other side. Right, solving equations 101, put everything with your variable, which is dy dx on one side, everything without your variable on the other side. Now, since everything on the left has dy dx, I can factor it out. So dy dx times 1 plus 4x. Don't forget, if I factor out a dy dx from dy dx, I'm left with a 1. And then equals 1 minus 4y. Now I have dy dx times something equals something else. Divide by it. So dy dx is 1 minus 4y over 1 plus 4x. Okay, so again, you cannot forget algebra. Let's try another one. 2y squared minus yx equals x to the 4th. So in 2y squared, I first differentiate it as if y were my variable, so 4y. And then it's the chain rule, so I need to multiply by the derivative of y, which is dy dx. Minus, again I have the product rule, so the derivative of y is dy dx times my other part, so x. I'm going to distribute that negative sign. So I have minus dy dx x minus derivative of x is 1 times my other function is y. And then on the right-hand side, 4x cubed. Okay, so don't forget you have to distribute that negative sign. And then again, I want to clean it up, so everything with a dy dx stays on one side. And I'm going to factor it out at the same time. So 4y minus x all times dy dx equals 4x cubed plus y, and then divide by what's in the parentheses. Okay, so 4x cubed plus y divided by 4y minus x. So it's calculus with the derivative, it's also algebra with the solving. So let's try another one. The square root of x plus y equals 20. First thing I want to do is change that square root so that it's in the power rule form, so x plus y to the 1/2. And then when I differentiate, I have the chain rule outside, so u to the 1/2. So I bring down the 1/2 and then take u, which is x plus y, to the negative 1/2. So here is my nu to the n minus 1. And then here is my u prime. The derivative of x is 1. The derivative of y is dy dx. Okay. And then I want to solve this. So I have the product of two things is 0. So one of them has to be 0. But if I notice, if this guy is 0, that can never happen. Because remember, to the negative 1/2 means it's in the denominator. So it would be this. And that's never 0 because of my 1 on top. Okay, so that term on the left-hand side of my product is never 0. So what I have underlined, this guy, must be 0. And then just bring the 1 to the other side. So dy dx is negative 1. Let's try our last one. X to the 4th y plus y to the 4th x equals 3e to the 4th. Both of those on the left-hand side involve the product rule. So I have the derivative of x to the 4th is 4x cubed times the other function, which is y, plus the derivative of y is dy dx times the other function, x to the 4th. So that's my first term. And then the second one, the derivative of y to the 4th is 4y cubed times dy dx times the other function. And then derivative of x is 1 times the other function is y to the 4th. And then 3e to the 4th is a constant. There's no variable there, so the derivative is 0. Okay. Again, I want to get dy dx by itself. So everything with dy dx, namely these two, are going to stay. The others are going to be brought over to the other side. So I'm going to have a negative y to the 4th minus 4x cubed y on the right. On the left, I have two terms that both have a dy dx, so I'm going to factor it out. And I'm left with x to the 4th plus 4y cubed, what's it, cubed, x. Okay. And then my last step is to divide by what's in the parentheses. So I have negative y to the 4th minus 4x cubed y divided by x to the 4th plus 4y cubed x. So sometimes they can get kind of messy. But again, just remember that after you've differentiated, it's just algebra, so don't let it freak you out. Put everything with the dy dx on one side, everything without the dy dx on the other, factor it out if you have to, and then divide by what you factored it out of. Okay, so practice this. Practice makes perfect. Try out the homework. Let me know if you have any questions. Thanks.